Where'd the name Weaviate come from?
Weaving the model and the database together. So it's like this is something we're still working on as well. If you take a generative model now, for example, is if you look what's happening under the hood, and especially with the open source models, if you just have an afternoon to spend, just go to the Transformers library, and then if you use a generative model, if you use something like GPT-2, which is relatively lightweight, then you see that there's a function that's called generate, and then if you go in generate, you can dive deeper into the actual attention mechanism and see how it works. And what's very interesting in that is like, a lot of vector embeddings involved in that, right? What we do now is still very primitive. Weaving, if you will, the models and the database more closely together is something that's happening. This is also something we're working on. This is also why I talk about Weaviate as being like AI native. And what I mean with that is that you really start to intertwine with the models, right? So it's not traditional way of storing and searching through information. It's really in harmony with the models, which is very different. And that's also why, yes, it's also what we said in the beginning. Yes, technically speaking, Weaviate is also a search engine. Yes, there are some overlapping use cases, but the new stuff that we see happening, and I'm not even talking about RAG stuff. I'm talking what comes out of that, right? Generative feedback loops, that kind of stuff. You just need dedicated infrastructure for that, and that's what we're building.
But models didn't exist when you started Weaviate.
It was a model, right? So in the end, Glove is a model. It's just what people do. It's like what we didn't do is we didn't do inference on the model. But theoretically speaking, we could do that. Basically, what it did was because it was only like a corpus of words, the famous bag of words. So how many words were in there? I don't know, 50,000 or something?
Okay. Words in the English language, you mean? Or yeah, something like that, yeah.
Yeah, so, and what was very interesting to see, so you saw like particles, like were very much in the center of the effect space. But what they basically did was that they trained the model, did inference on the model for all those 50K words or whatever the number is. I also remember from back in the day that you had to set you took a corpus that was after Wikipedia. Back then we thought that was a lot. And so you took Wikipedia and then you had and then you created the bag of words based on threshold how often the word was in the total corpus.
Yeah, like a term frequency.
The term frequency, yeah, exactly. And so then you trained a model and then it did inference on the bag of words. And then out came a CSV file with word embedding. But theoretically speaking, you could do it like as in real-time inference, where we just, okay, word, what's the embedding for that word? So that's how we do it now. But theoretically speaking, it's the same thing. It was just there were like a lot of abstraction layers between inference and storing the embedding in the database. And like how we remove that now, that we do direct inference on the model and store the embedding in the database. That's going to move even closer together for the generative models, where we start unpacking those functions and say like every time an embedding is needed, we can do that directly in the database. So for example, if you look at the generative models, so one way how they speed them up is something called the KV cache, which is the
Key value, yeah.
And based on during inference, if you can cache certain things, right? That's now done just in memory, but you could also do that in database. That's what I mean with like these. So if the model is, there's a camera. So if the model's here and the model's there, we just keep removing steps and bringing the database and the model closer to each other.